Hey everybody, how are you doing? It's been a moment, but I'm back again. Today we're going to look at render to textures and render layers. And while doing so, we're going to try and make this sort of volumetric lighting setup. So let's get started. So let's start with looking at a render to texture and render layer nodes. I think a lot of people are confused by exactly what they do and what their purpose is. They're very similar in ways, and yet they function in totally different methods in terms of what you're trying to accomplish. So let's start with a render layer. I think that one's easier to understand. What it is this is essentially, you can think of it like a mini root node. It's something that lets you make a sort of subcomposition or the equivalent of putting another layer into this layer. But this is essentially most commonly used when you want to apply a different set of post effects to certain areas of your scene. So a really common one is people might add glow, but it affects too many parts of your scene. In contrast, a render to texture node is a way for you to render out essentially a 2D texture. It's like the generator nodes that exist in Notch. These are essentially render to textures in their own right. What it does let you to do, in contrast to the generators, is that it lets you place cameras, lighting, objects into your render to texture. And this is the key to how we're going to do that sort of dappled lighting that I showed you earlier. So let's put this render layer aside for now. Let's focus on the render to texture. You'll notice that one of the main differences here is that your render to texture node has a setting for your width and height. What that is it's a resolution. Because you're rendering something to a texture, you have to tell it how big do I want this texture to actually be. You want to be careful about making this too large. It'll affect your system performance, so try to make this as small as you can. Same thing with render layers. If you have too many render layers in a scene, that's going to really eat up your graphics card texture memory because it has to render each of these layers as its own entity, but to apply post-processing to. So I've had projects I've worked on where there were like 6 or 7 render layers in the scene as we were developing, just kind of adding things. And ultimately the scene didn't run real time anymore and we needed it to. So I ended up doing a bunch of cleanup, figuring out when do we really need a render layer, when do we not, and ultimately turned those 7 render layers into just one. And that alone, with no other changes, got our scene running from not anywhere close to real time to real time with some margin. So when you use these nodes, just be really careful and check your performance as you go. So let's make the item that we want our lighting texture to look like. I'm going to start with just a basic particle system because I love particle systems. So as always, you have your particle root. Let's add a primitive emitter of some sort and a point render. So normally we would connect our particle root to our root node. But in this scenario, we're going to treat this render to texture like a sub root node. So we'll connect this to our root node and then connect our particle root as a child of our render to texture. A way for you to preview what's going on in this render to texture are some of these options here where you can show render texture, you can show the alpha, or you can disable it entirely and basically ignore this node and treat it as if your particle root was connected to your root node. So let's try disabling it first. And you can see that right now we basically see this default particle system. If I turn this off, you'll notice that it has disappeared because it's only being rendered in this texture and not in our main scene. So to view it, we can check this box and it basically shows you a little window up here of what your texture looks like. And the reason that it's squashed right now is because of my camera view. So right now it's using basically my orbit view camera here to render. And that camera has a 16:9 aspect due to my project. So that's something that's really interesting about render to textures is they actually use a camera perspective. And if you want your texture to be rendered, for instance, in our case, we want it to be orthographically rendered, then we have to actually define the camera so that it renders it from the correct perspective. So let's add a camera to this render to texture node. You'll notice this changed immediately. And now when we orbit, it has no effect on that. If I have this disabled as we orbit, you'll see that this texture is also respecting this camera orbit. So with this camera, we're essentially rendering just this particle system here and nothing else that's going to be in our scene. The camera is a little close, so I'm going to pull it back a little. I'm also going to make it orthographic actually, and when you make it orthographic, you're going to use the zoom to control it. So when you move in position, the orthographic really doesn't respect your distance since it's looking at it from a parallel projection. So we'll change our zoom to 1 and you can see this nicely fills up our texture right now. So this is way too many particles. I'm going to reduce this down a bit. I think default is 30,000, so we're going to do just 100. So turn it way down. I typically also turn it down in our particle root to match whenever I decrease our particle count. And I'm going to take a moment here real quick to lock the update rate of our particle system so that it always runs the same way no matter what. So you can see here that we've got some dots, and we can basically use this to texture onto a light as a projection image, and that way the light shoots this source down. So I'm going to add a light now, and this light we want to be in our main scene. I'm going to turn on a little bit of scattering intensity here so I can see where it is, and we're going to, for now, just move this light straight up and have it point down. So I'm going to have a target for it that's at the origin, and I'm going to just move this light upwards. So there we go. We have a light that's pointed down, kind of like a, I don't know, just like overhead lighting. And what we're going to do now is we're going to feed this render to texture into this projection image. So just remember that when you use a render to texture, it essentially turns your render here into an image, or like a 2D texture. So we can actually feed this into video nulls. And if we preview that, you'll see our video null is taking this texture and basically sampling it. So you can do all sorts of post-processing and other stuff, but for now, we're just going to use it to feed straight into our light. So this first tab here, projection image, is what you want. And right away, you'll see that nothing's really happened. And the reason is without volumetric lighting, the scattering intensity doesn't listen to what the texture is, but your light is emitting in this shape. And to prove that, let's add a floor to our scene. I'm just going to use a basic shape. And you can see it is, in fact, lighting up in this dot format. I'm going to make this a plane so that we can just see it on the floor. There we go. So our light is emitting the texture that we've created with these particles. And that's essentially the basics of how you use a render texture. It's pretty easy. You can put anything you want in here. And with the finished layer that I have, I've included a few samples of different things you can do. Let's talk about volumetric lighting real quick, since we want these to be represented by actual rays instead of just this scattering cone and the end texture on the ground. So if we add volumetric lighting as a node, what this does is it tells your lights that it should listen to whatever images are being projected, as well as other shadows that it's hitting when it renders the volume of what the light is shooting out. So if we connect this to our root, you'll see right away it added some of these lines, and it doesn't look very good because of some of the settings in the volumetric lighting node. In it, you have to be very conscious about controlling your sample density, as well as your max depth range. So the max depth range is how far away from your camera view here that this will be rendered. And the further away you make this number, the more volume lights in your scene you will see, but they get rendered at a lower resolution. So if we decrease this, since this light is very close to us, you'll see that it starts to make these rays a little more clear. And our light isn't quite bright enough, so I'm going to turn up the brightness a little bit, just so we can see, or the scattering actually. So there we go. So you can see the rays, and as you change this max depth range, the higher you make this number, the kind of crappier it gets. And the lower you make this number, the better it will look. But at some point right here, this number has gotten too small for the distance that our camera is from the light. So it'll kind of appear, it's like a clipping basically. So you want to find a value here that's as small as you can get it while being sensible for how you're going to move your camera. So I'm going to set it to 8 right now. I think that's a pretty good range. And you can also increase your sample density to try to get rid of some of this effect. Be careful though, because this does increase processing load on your system. So you can see as you increase it, the rays kind of get filled in and start to look quite nice actually. I'm going to leave it at 2 for now. It's going to be a little blocky at the top, but this keeps performance pretty light at the moment, as you can see. I'm on a 1070 in a laptop, so it renders quite nicely. So you can see there that is proper volumetric lighting, and that's basically the fundamentals of it. Rinse and repeat for some other things, and you can make lots of stuff. You can, like I said earlier, also add post-processing to your render to texture, the result of it. So if we think these are too sharp and we wanted to blur them, we could do a radial blur on our entire texture. And you'll see that's changed how our light looks completely and made it a lot softer. Same with these particles. You can play with more rigid shapes. So for instance, if you did a line connection render instead of a point render, you would get some lines between them. Increase this distance threshold so they attach a little further. And I'm going to turn off use locality. So that's a lot, that's too many. So you can see there it's kind of rendering these lines instead of just the points. And when you enter this light beam, you'll get some really cool sort of ray effects. Almost feels like a laser. In your volumetric lighting, you also have some interesting parameters like smokiness. So this adds a little bit of smoke into your scene. I'm going to turn off this texture for now so you can see. So it adds a little bit of smokiness into your scene, and you can actually increase this past one if you'd like. So you can see there, it's a little extreme probably. You can also change your smoke scale, so how large or how small your fog is. And you can kind of do interesting lighting simulations with this sort of stuff, right? So far we've been doing particles. Similarly, we could replace this particle system entirely with just a shape. So let's preview this so we can see what we're doing. So if we make a shape, let's make it like a torus here. And I'm gonna face this so that it's facing the camera like a ring. And I'm gonna give it a little material so that it lights up and ignores the lighting. So with this material here, we've just made it fully emissive. It's a ring, and I'm gonna make it a little thinner. And you can see here we've made a really nice ring for the volumetric light. So you'll notice that before I added this material, this torus is actually being lit by a light above. And that's this light here. So the interesting thing about these render to texture and render layers is they actually look at the lights that are in your scene. So this light right now is the one that's lighting it up, as you can see, even though it's not connected to your render to texture at all. It's something that you should be aware of. It's like, oh, why does my scene not look the way that I would expect? Just remember that it is evaluating certain elements in the rest of your scene. Like this isn't going to evaluate your floor. It's not going to look at other shapes, but it will look at things like cameras and lighting, especially if you don't have any defined. And you'll notice in the inputs here, there's excluded lights, affecting lights, and rendering enabled. And you can use these affecting lights and excluded lights to tell it which lights should be affecting the things in the scene and which ones shouldn't. I make a second one and I move it over a bit. Let's see if I move it over a bit and I make this one a different color. Then if I plug this one into affecting lights and this one into excluding lights, well, that seems like a bug. I think I'll have to report that to the Notch team. It may be because I don't have deferred lighting enabled. I wonder if that's actually, yeah, that was it actually. You need to enable deferred lighting within this node. So without the deferred lighting enabled, I guess it doesn't listen to those inputs. Not a bug, probably my bad. So yeah, you can also change the width and height of your texture here. So if you don't need your texture to be as high res as it was, you can decrease it. And if I go really low here, you'll see that it actually affects how my scene looks inside it. There's just not enough pixels. And if you make it really large, at some point you're going to stop noticing how much crisper it is, right? So like it doesn't look any different here than when it was at 1000. 3000 doesn't look any better either. So, you know, play with the values a bit, see what you get. Sometimes in volumetric lighting, you'll get these sort of gradations here, these kind of like almost like more. And to solve this, the problem is that the shape here has a really sharp edge, and when the volumetric lighting is trying to render a really sharp edge, it tends to make these sort of weird aliasing lines. The best way to solve that, I found, is to just give it a little bit of blur. So that's way too much, but if you give it a tiny bit, you can see that more starts to disappear, and your lighting actually ends up looking more natural because it diffuses a little more like lighting should. And the smoke is a bit too much for me right now, so tone it down a little bit. There you go. So that lighting looks much more natural to me when you pass through it. And you can do some really cool animations with this, as you can see. These lines that you see here have to do with that sample density. So if you change this, it should, oh, maybe not. It should change the number. Oh, here we go. It's depth slices. So that will have an effect on how many rings you have. And same thing with this number, like sample density. If you go too large with it, it's going to hit your system performance is going to take a hit. You can see here my laptop's starting to work a bit to render this, but you can make things look quite nice. So if we place something in this scene, like another shape or something, let's put a sphere on the ground. Make it a little smaller and raise it up in the air. And we can animate actually things in our render texture. It's a proper layer. So we can do a math modifier, and I'm gonna scale this shape here. So I'm gonna do scale X, scale Y, and scale Z. So uniform scale. And the sign is a little faster, so I'm going to slow it down. And you can see that the lighting actually hits your objects in the scene here properly. So it's really nice that with the volumetric lighting, you not only get the rays, but you also get the proper impact on the object. And you can see right now that it's actually shooting through the sphere. So let me pause it when it goes onto the sphere here. So you can see that let me turn off my bounding box. So you can see it's actually shooting through the sphere, which is not correct. I think we just have to turn on shadowing in our light. There you go. So now it casts a proper shadow and is obstructed by the sphere. One thing you can control too with these is the cone of the light. This will affect how your texture basically radiates out. So by changing that, your texture gets narrower at its whitest point and smaller or larger depending on how you want to do it. So this is a pretty nice effect right now in terms of lighting an object, very moody. And I'm gonna decrease our sign scale a bit there. So if you look at this from inside, right, this is quite cool actually. You can use the same technique to render looks that are kind of laser-like, right? If you have really sharp lines and do a line connection, you can make things look like lasers and whatnot. So with this shape here, let's line it up a little bit. I think this one's my floor. And tweak the roughness a little and the metallicness. And so, we might want to, for instance, color our sphere a little bit, have it like glow slightly. And one thing that we can look at now is this render layer. So if we wanted to give an effect that creates some bloom on this object, we could add something like Glow 2, which is a node I highly recommend you guys check out with this new release 9.23. I like Glow 2 a lot more than Glow 1, I guess. Glow 2 feels more like a bloom to me, and Bent says it's resolution independent. So I haven't had too much of an issue with that, but I think Glow 2 just looks nicer. So you'll see here that we've got the bloom, but it's also affecting our light, and maybe we don't want that. And that's where a render layer would start to come into the picture. Is you can use render layers to isolate elements in your scene that you want to post-process differently than the rest of your scene. So in our example here, I want to add post-processing to just the sphere, but not the light. So what I would do is I would connect our render layer, think of it again like a sort of mini root or subroot, to our root node, and I'm going to connect our sphere as a child of that. And I'm going to move this glow into just the render layer. But before I do that, you'll notice that everything got really blown out. Why is that? It's the same thing as your render to texture. This also listens to lights in your scene. And you don't have to give a render layer a camera, because a render layer is thought of as in the same 3D space as your scene. So a render layer will just look at whatever your viewpoint is and use that. Whereas a render texture is not in the same 3D space. It has its own 3D space to render from. And even if I were to exclude this light, the problem now is that it doesn't light up this sphere anymore, because this light is excluded from this subsystem. So I can't exclude this light. Instead, I have to just also make it volumetric so that the parameters match. Because I do want the light in this scene. I want the light in the render layer as well as the main scene, so that it lights up the sphere. So now let's apply that bloom with the Glow 2. And the alpha blending is sort of screwed up. So with render layers, you have to be really conscious of alpha blending, because it still has to blend objects together in some way. And with the glows, to fix that, often you just have to enable glow difference as alpha. So there you go. We have a nice bloom on the sphere while not applying it to this light. And then we still get the lighting effect on the sphere. And that is basically how you use a render layer to segment post effects out. You could also have this sphere glitch a little bit, for instance. So that way this glitch acts on just the sphere and not the rest of your scene. So that works quite nicely as well. See, if I apply it to the scene, then everything glitches out instead of just the sphere. So render layers are really useful for, again, segmenting your scene and getting interesting things out of it. That's about it, really. I made more stuff in the example that I included so that you can see different ways of creating interesting things. I mean, I'll switch to it right now and we can just look at it. I want to keep this tutorial a bit shorter because I know in the past I've gone kind of long with them. So trying to be a little less long-winded. You'll see here that, this is really similar to the one that we just made. It's basically a circle or a torus that is growing. This one's using a cloner. So this set right here, you can obviously use cloners within render to textures, and you could do all sorts of interesting things, kind of like lighting gobos or things like that. Here's the dappled lighting that we made at first. In this instance, we're also rotating the light slowly, kind of like a disco ball. And then finally, this one here is line connection render with a force pushing the particles out. So, or a velocity pushing the particles out. So as the lines are connecting, you're getting this nice sort of laser-like look. And one thing I love doing is going into the rays of these lights, and you can see it's getting quite heavy, but basically looking up into them and taking part in this sort of volume experience. So it's really nice. Let me focus on this light here. And then if I look into it, kind of a cool effect there, right? So, just remember some of the things, like as we pan out here, because of the depth range that I've set in the volumetric light, they'll disappear and then appear to save system resources. And the interesting thing about volumetric lights is that if you get really close to them in the rays, that actually takes more processing power to render. So as I get closer here, you can watch my GPU time start to spike. So just be careful of this if you're trying to make real-time applications. Volumetric lighting is quite heavy, and sometimes you won't be able to do it. But even without it, you can still use render textures to cast certain types of light into your scene, which is useful. So this volumetric text here is just a render layer, kind of like what we made the sphere before. And I'm giving it just a tiny bit of glow and this little glitch effect. So this is basically what we had before, and there's not much more to it, really. I just made 4 lights instead of just 1. So feel free to dig through this, play with it, make your own dappled lighting. I'm interested to see what you come up with. But I think I'll end the tutorial there. I hope that was useful. Just remember the differences between render to textures, render layers, when to use them, when to not, and save on resources. And don't forget to just experiment and play with it. And if it doesn't work quite the way that you would expect, just look at it again, try plugging things into excluded lights, affecting lights, and just remember that, they are a part of your scene still, even though they can work in a separate format sometimes. And definitely don't forget to use the preview functions. These are extremely useful for troubleshooting. And if something isn't working, work your way back to the start and figure out what exactly is getting rendered into the texture, how is that being processed, what's happening down the chain. Always trace your way back up the river. So I think that's it. Hope you learned something from that, and I look forward to seeing what you make. Take care and see you next time.